All right, let's go ahead and get started. I believe this is video number 7. So let me put 7 up on the top there. There we go, video number 7. All right, so we have matrix A has elements 10, 11, 12, 13. Matrix B has elements 3, 4, 5, 6. Create and multiply create a row and column matrix so that you get a 1 by 1 matrix. All right, now remember, a 1 by 1 matrix, there's your 1 by 1 matrix. Very simple, but we got to set the problem up. So here's what I'm going to do is I'm going to set matrix A up as a row matrix. 11, 12, 13. Column B has to be a column matrix because if they were both row matrices, there was no way that you could multiply these. Now, remember from the last video, this has a dimension of 1 by 4. This has a dimension of 4 by 1. I can multiply these because the two outer numbers match. And my two inner numbers match, and my two, I said inner, out, inside, and my two outer numbers is 1 by 1. That's my dimensions. So it would be a 1 by 1 matrix. All right, now, remember how to start this. This is your row matrix. You're always going to move to the right. This is your column matrix. You're always going to move down. So I'm going to start with 10. I'm going to start with 3. 10 times 3, I'm just going to write right here, is 30. Plus 11 times 4, 44. Plus 12 times 5. 60 plus 13 times 6. I believe that's 84. Add all that up and I will get my answer. I'm just going to go write it down here because I'm going to go ahead and dive into the next question. Alright, so I believe this is 218. Alright, now it says use scalar multiplication to multiply your answer by 5. Scalar multiplication is like multiplying a parenthesis. You know, like you guys are used to seeing. If I had a problem that looked like this, 5 times 2, that's easy because that's in a parenthesis. Same concept here. 5 times 218. So let me go ahead and cross that out. That gives me a number that I can't think of at the top. There it is. 1090. There it is. There's my answer. All right. Matching. There we go. You can see it all now. Element, number inside of a matrix, row matrix. Now, the row matrix, like G and option A. So the row matrix and column matrix, everybody gets confused. Well, if you're going to get it wrong, you're going to get confused. What I recommend is actually creating one. So like example A, that is a 3 by 1 matrix. 1, 2, 3. 3 rows, 1 column. That is a tall column. That is a column matrix. A row matrix is more of a flat column, so like this 1 by 5, 1, 2, 3, 4, 5. There you go. There's a row matrix. Everything else you can see. All right. Now, question number 45 deals with a Leslie matrix. All right. So remember your population matrix. All the 15s will go in here. 15, 15, 15, 15. Now the birth rate goes down the first column. So 0, 1.1, 0.9, and 0. Now if you remember in class, the survival rate, that's the weird one. That starts at the top of the second column and runs at a diagonal. 0.9, 0.7. Everything else are zeros. Alright, now it says multiply the population matrix and the Leslie matrix together. Alright, so the population matrix has to go first. 15, 15, 15, 15. I'm going to pause the video just to save a little bit of time here. Alright, so from here, we're now going to multiply the Leslie matrix on the population matrix times the Leslie matrix. This is a 1 by 4 matrix. This is a 4 by 4 matrix. So together, middle numbers match. The outer numbers tells me my answer. 1, 2, 3, and 4. I'm probably going to run out of room on this, but I'm going to try my best. Remember the row matrix, you're always moving to the right. Your column matrix, you're always moving down. And I'm labeling my columns. So when I do this, row 1, column 1, I start with 15 and multiply by 0, which gives me 0, plus 15 times 1.1, which gives me 16.5. And I did not make my 15 times 0.9, gives me 13.5. And then plus, I'm going to put I know this is weird, 15 times 0 plus 0. All right, I had to do it right there because I kind of ran out of space here. Now, this right here is row 1, column 2. And of course, if you know how to multiply matrices, feel free to go ahead and fast forward this part. 15 times 0.9, I believe it's 13.5. Remember, I'm starting with row 1, column 2. 15 times 0 plus 0 plus 0 plus 0. Which do you really need to put the plus zeros? No, but it's just good math to know. All right, so this one right here, row 1, column 3. 15 times 0, 0 plus 15 times 0.9, 13.5 plus 0 plus 0. Again, I'm putting the 0 because I ran out of space on my blank. Lastly, row 1, column 4, row 1, column 4, 0, 0, 0 plus 0 plus 15 times 0.7. Gives me 10.5 plus 0. All right, so now let's go ahead and take all these and get my answers here. Babies. I look at the baby row or baby column here, and that was 16.5 plus 13.5. I believe that's going to give me 30. This will be 13.5. This will be 13.5. And lastly, this will be 10.5. All right, so let's answer some questions. How many possums were born? Well, let's go back to my answer. 30. How many possums survived? All right. Now this is a little, this question, you got to think about things here. My survivors, well, I'm sorry, actually, let's see. Nope. Sorry, I was thinking of another question. I'm sorry. 13.5 plus 13.5 plus 10.5. Those are your survivors. See how the matrix is marked here. So 13.5 plus 13.5 plus 10.5. We had a grand total of how many possums survived? 37.5. And if you want to say 38, because what is 0.5 of a possum? Never seen one before. Now, lastly, what is the total population of possums? Now, there's two ways you can look at this. 30 were born, 38 survived. Just add the two up. But if you want to go back to your matrix, 30 plus this plus this plus this. See, notice how it's total population. See the little way it's written here? So add it all up, and you would actually get 67.5 if you do the matrix, but again, we're just going to round to the nearest whole possum here, and that's 68. All right, now this is cycle 2. Notice that all these are blank. 1, 2, 3, 4. Hopefully you can see a pattern here. 1, 2, 3, 4. So 30 babies will be here. All right, 13.5, 13.5, 10.5. So 13.5, 13.5, 10.5. Now it says create a Leslie population matrix again. Okay, so basically what we're doing for this one is it's literally this question again, except we're now going to be using these numbers. So the population matrix is 30, 13.5, 13.5, and 10.5. And we are going to use the same Leslie matrix. So that will be 0, 1.1, 0.90, 0.9000, 0.900, 0.70. Okay, now I'm going to pause the video. You've already seen me do this one time with this, so I'm going to pause the video. I'm going to go ahead and give you the answers. All right, so let me pause it real quick. All right, so here's my answer right here, and I just went ahead and put the lines in there just so you can see the separation of my elements here. So how many possums were born? Remember, the first number in the matrix tells you how many that are born. There it is. See the babies? So how many possums were born? 27. How many survived? Remember, it is from here to there. Those are my survivors. So 27 plus 12.2 plus 9.5, you get 48.7 possums, which we'll just round to 49. And then lastly, what is the total population of possums? Remember, it's everything, basically all the elements added together. So we're going to say 49 plus 27, and that gives us 76. So the new population of possums is now 76. So we're growing from the first cycle, which was 68. All right. So that is pretty much where I'm going to stop, because I believe at this point we're going to dive into a lot of matrix stuff. So for all the matrix stuff, stay tuned for video number 8.